Good morning, everybody. My name is Claudia Vivalda. I am the supervisor of the internship of Antonella El Kaddoum. This workshop, this webinar has been organized to present her final report concerning the issue related to legal and regulatory aspect for CCU deployment and with focus on risk assessment. And the agenda of today will be a welcome from our president, Mr. Giampiero Celata, a short introduction to CCUS subject from myself, and then the floor will be for Antonella, that will present your internship work. We will finish with the session with the question and the answer, and we expect to finish this workshop at 1 o'clock. Just a very short background about the webinar. We have had this first student from Politecnico of Torino as for an internship, a curricular internship, and because we needed some support for the update of our CTNE Technology and Development roadmap. In our roadmap, one of the technologies that are promoted are carbon capture, utilization, and storage. And what we asked Antonella was to have to make a literature review concerning the legal and regulatory issues for CCUS as a commercial deployment, and then to apply to a case study the most popular risk analysis methodology identified during the literature review. Having said that, I give the floor to Mr. Celata for the welcome to the participants.
Thank you, Claudia. We agreed that my introduction would be in Italian, but I realized that there are quite a number of attendees which are not Italian, so I directly switch myself into English. So thank you for coming. Good morning, everybody. We are very happy to have this webinar today as a national energy technology cluster. We started very few weeks ago to cooperate with some Politecnico or Italian universities for these internships with students. And this is the first one with the Politecnico of Turin. Then we have also an agreement with Politecnico of Milan. And then we are finalizing an agreement with Sapienza University of Rome. A few words about the cluster. The cluster is a public-private partnership under the auspices of the Italian Ministry of Research. We have about 80 associates or members, and we work in the frame of an action plan of research, 3 years an action plan. And the action plan is made of a technology roadmap, which is defined in the frame of macro areas, which covers all the aspects of energy. So one of these is hydrogen and CCUS. So for us, it's quite an important topic because we realize that energy or ecological, as you like, transition cannot be made with just one solution. So should be made in the frame of the technology neutrality. So all the possible technology has to be used. So renewable sources, energy efficiency, use of electric and hydrogen vectors, and last but not least, the capture of the CO2. And when we capture CO2, we have two choices. One, we can use it. Second is to store the CO2 wherever it is possible. And this, I guess, it's the main topic of the talk of Antonella today. So this is my introduction. I thank you very much, all of you, for attending the webinar, and especially Antonella for the trust she has in the cluster and the possibility to have the internship with us. Thank you so much. Okay.
Thank you. Very, very short but very to the point introduction. I take back the floor just for a very short view on where we are at the European level with industrial carbon management. In February this year, the European Commission published a communication with the title "Toward an Ambitious Industrial Carbon Management for EU." And as probably some of all of you knows, the European Union is committed to achieving economic wide climate neutrality by 2050 to limit global warming to 1.5 relative to pre-industrial times. In the same time, it is implementing a comprehensive policy framework to reduce emission by at least 55% by 2030 compared to 1990 levels. And the Commission has laid down a groundwork for the EU policies on this. And you have the reference to the communication here if you are interested in reading it in more detail. I will give you just some just a minute about this. The first point is that the carbon management strategies in EU is in itself an essential complement to the mitigation of the greenhouse gases emission. And the Commission recognizes that industrial carbon management technologies are part of the solution toward achieving the climate neutrality by 2050, as already said also in the introduction by Mr. Celata. And the main focus will be on capturing CO2 from process emission during this decade, as well as from emission from fossil and biogenic CO2 sources. And one point that is important to underline is that the EU is relatively well positioned on CO2 capture technology and in terms of research and innovations. And these technologies are moving toward here 2040, where close to half of the CO2 that is captured annually would have to come from biogenic sources or directly from the atmosphere. So there is a research and innovation activity concerning the development of new technologies or advanced technologies for this purpose. And for us as a cluster or energy cluster, it's very important also to underline that carbon capture requires significant additional energy to power this energy-intensive process. And also in the case of biogenic carbon, the sustainable sources of biomass. The focus of Antonella's work is mainly on the storage side, where the amount of required energy to drive this process is less important than for capture. Then going on, the strategies that is done, it's proposed to face the various challenges required by EU-wide industrial carbon management are based on three main pathways. From the first one is capturing CO2 for permanent storage. The other one is removing CO2 from the atmosphere, so not only from fossil or biogenic sources, but also from atmosphere with permanent storage in underground. And the third one is capturing CO2 for utilization. And here you can see how it is expected the process of the capturing and the different and the share of captured CO2 by origin. In the top part, we see that starting from today, almost today, 2030, most of the CO2 captured will be for storage. Then going on, it is expected to have even more captured CO2 for storage, but also almost half of it for utilization. At the same time, we can also see that today most of the CO2 is produced by process emissions and hard-to-abate industries. While going on during the year, it is expected that this emission will be reduced following the energy transitions, and this is explained why there will be more captured CO2 from the atmosphere. And another important document, EU document, is the proposed Net Zero Industry Act. And in this act, it is, among the other subjects, it is expected that the EU will store annually at least 5 million tons of CO2 by 2030. And this means that the EU have to invest in initial infrastructure to reach these objectives. And many European countries, today they are 20, have already included these industrial carbon management solutions in their draft National Energy and Climate Plan, and Italy is one of them. And now, last point is that despite there are policies supporting industrial carbon management and there are projects planned, there are very few operational large-scale projects, and you will see this in the presentation of Antonella and as a result of her work. And today we are experiencing a number of challenges, and some of them, the solution, or at least vision for a solution of them has been part of the work of Antonella, and in particularly among these issue, we can highlight difficulties in building a viable business case, lack of a comprehensive regulatory framework across the entire value chain, and the first businesses are involved in building carbon value chains also face specific cross value chain risks. We will be talking about risk as well, such as liability for leakages. And another point that is to be highlighted is the insufficient coordination and planning, especially in cross-border context. And finally, insufficient incentive for private and public investment to prove that the business case for industrial carbon management. With this last slide, I give the floor to Antonella, and in a way that she will enter more into detail of carbon storage and the policy and the regulations that are available today or in preparation.
Thank you, Mrs. Rivalda. Thank you, Mr. Chalata. So I'll be sharing now my screen.
Yes.
Can you see it?
Yes.
Okay, perfect. So today, as it was well said in the introduction from both of you, we will present legal and regulatory issues for CCUS deployment with focus for sure on risk assessment. So in my presentation first, I will speak also a bit about the carbon capture and storage, its goal, the main types of storage, and the project life cycle of a CCS project. Then we will focus on the risk assessment part because it's a very important part during all the life cycle of a project of CCS. Then we will go into the rules and regulations to know more about the issues and the rules and regulations state all over the world. And we'll focus at the end on Italy. And at the end, we will give some actions that could help for the deployment of CCS. So first, about carbon capture and storage, how it started. All the scientists have already spoke about climate change effects, and we are seeing it nowadays, like ice sheets are melting, sea level is rising, and the temperature is rising. So all these effects are due to one most important thing, which is the greenhouse emissions. The greenhouse gas emissions are for sure natural on the Earth, and they support life on the Earth. But the main problem is if we have excess of these emissions, and mainly the CO2. CO2 is one of the greenhouse gas, and we have a lot of emissions of CO2, especially from industrial processes and from power. So all of this pushed the governments for an agreement that was made in Paris in 2015. And to have a net zero emission goal, which is keeping the global warming to not more than 1.5 degrees Celsius, and the emissions needs to be reduced by 45 or 50% by 2003, and at the end we reach our net zero goal by 2050. As Mr. Chirata said, we have a lot of technologies that could help, like the renewable energy, the hydrogen. One of the most important is the CCS. So CCS can provide decarbonization potential and will help us with a low cost to attain net zero future goals. In the IEA, International Association of Energy and Net Zero Emissions by 2050 scenario, it's estimated that 5.9 gigatons of CO2 would be captured in 2050. This is a map about some of the CCS projects till now. Some of them are in construction, others early development all around the world. We will get into details later on in the presentation. So what is CCS project? So first, we start by capturing CO2. It can be directly from the air or from power stations and industrial facilities. Then it's transported by ships, by pipelines, either for a reuse and to create other services or to store. We store it underground, and we will focus on the storage in this presentation. So where we can store the carbon. We have three main possibilities: even saline formations, depleted oil and gas fields, and unconventional storage resources. So if we speak about saline formation, there are porous media underground with non-potable water. We call it brine water. They are very wide in the world, so 98% of the world's estimated CO2 storage resources are in the saline formation type. But the main point in this type of storage is that we don't have specific data to characterize these sites. So we don't have like the exact number of capacity that we can store in, and this can increase the cost for sure, because we need a lot of work to do in order to characterize this type of storage. Moving to depleted oil and gas fields, depleted oil and gas fields are already oil and gas reservoirs that were produced and depleted before, and we can use them again for storing CO2. So after production, the pressure will be lower for sure because we removed the hydrocarbon from it, which means that it will be easier to inject CO2. And for sure, it's already characterized during the depletion phase and production phase, which means that we have already data that can help us to characterize our storage site, and it will be easier for us to have more data to know the injection capacity and injectivity and all of these requirement information, and also the existing infrastructure. We already have wells that we use them for the production, so we can use them again for sure for the injection. But with all this infrastructure, we should be aware that we should do an assessment to ensure that the wells and all the other equipment are still fit and we can use them again, because otherwise we will have a lot of problem. Unconventional storage resources, there are not many, but the researchers are going on them to know if there are a lot of them. It's basalts and periodites, which are rocks that can react with the CO2 and activate, and we convert it into solid minerals, and it stay on underground. Also, unminable coal seams, it can absorb the CO2, and also ongoing researchers are going about this. And also organic shales, which are rich in organic matter, and they can absorb CO2 like coal, but also researchers are going on over this type of resources. So after knowing how we can store, where we can store the CO2, now we will go into the storage project phase by phase. So to know if this place or the storage type is suitable for our storage project, we should do an assessment and the development on different phases. First, we have the regional and site screening. So we have geological data, we can assess them, the legacy well records. If we already have wells in the site, we can see the properties and the technical issues of it. Regional geographic data to determine if there are existing pipelines, and social and demographic data to see the influence of on the public perception. So after having an idea about the region where we want to store, we go into detail into the site selection. After choosing a site in this region, we go also again in detail for the geological data, legacy well records, if the site is suitable. So we do a lot of assessment and models to know, and we should have also requirements and legal requirements to be able to do the site selection. And after this, we can say, okay, the site is good for us and we can store in it. So after having this, we go into another characterization using our existing data to go in site-specific technical and non-technical assessment. And if we pass this phase, we will have another detailed characterization, which ensures that public outreach and data acquisition are performed in a cost-effective manner. So we do a lot of characterization because it's very important to assess every step in our storage project. After doing this, the storage developers would say, okay, now we can, and we should do a decision if we can invest in the site or no. So after completing all the engineering studies, the project planning, after having all the permits for sure, and they receive all the environmental consents about this storage place, and they conduct an environmental and impact assessment, which is very important from the environmental part. They can take the last decision about if we can invest or no in this project. So as we already said, a lot of assessment should be done, and the risk assessment is a very, very important part during all the stages of the storage project. So this risk management processes are a key part of CO2 storage in development and operation. We have two types of risk, socioeconomic and technical risk. So when we speak about socioeconomic risk, we have a lot of point of view, and each point of view takes this risk on a manner. So let's think about site developers or the owners. For them, these are market risk, and they related more to the sunk costs and to the transport operators and all the resource development related to market risks, so money. Regulators and policymakers, for them, these risks are more related to environmental and public safety, for sure, because they are regulators and policymakers, so they care more about the public perception. For the finance and insurance industries, these risks are related to long-term liability and if they can affect their investment, because they don't want to make an investment and lose their money at the end, for sure. Okay, so the risk, for the second type of risk, we have the technical risk. These risks are the one directly related to CO2, and they are performed during the different stages of the CO2 program. It's site dependent for sure, it's different between an offshore and onshore site. And if the risk assessment were very well developed during the operations and during the modeling, this risk should be with low severity. Here I can present 5 of the main type risks that we care about: site performance, health and safety, environment for sure, containment failure, induced seismicity, and resource interaction with other resources. So to understand it more, we'll do a real case risk assessment example. This is a site in Northern Adriatic Sea, which is the sea between next to Italy. It's an offshore site. We had the depleted gas reservoir type storage, and the depth was 2,000 meters. The production phase that was made for 30 years, and 2 production wells were used for this reservoir. Injection phase is being modeled nowadays, and the ejection phase is modeled for 30 years, estimating to start it in 2025. And the same wells are reused for the injection. So if we want to focus about the risk related to leakage of CO2, we could have leakage from the well, or capillary failure, or induced or capillary failure. So how it works, if let's say we estimate that we will have leakage from the well, the possible cause will be for sure a well damage, because we already reused a well, so we have a damage after the production phase that happened. So what will happen, we may have leakage of CO2 to the surface and environmental damage and soil acidification. How much it could happen and what is the severity? This we can find it in this risk matrix that I show here. So likelihood is is how much this event could happen, likely, possible, unlikely, and the severity is how much is severe for us. So for example, a leakage from the well, it's the L is 2 and severity is 3, so we are here. And it's severe, it's a yellow color. As well, I will do for all the other cases. So in the risk assessment, we provide like mitigation methods that could help us to reduce this risk. Which we can do here is a monitoring program that can help us monitoring the well. And we will have another good assessment for the legacy wells. Another case is the cap rock failure. Also, it can't happen by surpassing the fracture limit due to pressure, because when we inject, the pressure will increase for sure. So if we inject with a high rate, we could surpass our threshold pressure and we could cause a cap rock failure. For sure, it will cause environmental damage, soil acidification, same likelihood and severity. What can we do as mitigation? Assessment of the sealing capacity of the cap rock or pressure management. Induced seismicity is the expansion and contraction of reservoir during injection and production phases. So what will happen? Seismic events, environmental damage for sure. And what we can do is we integrate monitoring to detect subsurface and surface pressure. We should review the indication of seismicity in the area or in the site. Faults, it's also because of pressure changes. Also, we can have leakage. It could happen more because we inducing this fault. What can we do? Also pressure management, and we can review the geological data if already there were a fault in the site and we disregarded, and during this injection we reactivate the fault without knowing. Now, after finishing all the storage phases, we can focus on the legal and regulatory frameworks for CCUS. So why they are important? First, they scale up the CCUS technologies. For sure, if something is legal in a country, this will improve like the investment in it and will force people to be able to work more in it because it's legal already in the regulations. It's an effective stewardship of CO2 storage site, protection of the public health and environment for sure, safety of the CCUS, and clarify the rights and the responsibility of CCUS stakeholders and operators. So if we have regulators, this all could help us to protect more and have more safety. The issues related to CCUS, the International Energy Agency also detected 25 issues that could be maintained into 8 categories. Each category represents a part that represents an issue of the key legal and regulatory for CCUS. I will go on them category by category. Defining the regulatory scope, it's more about classifying CO2 and the ownership of CO2. So if a problem happened, know who is responsible about this CO2. Environmental reviews and permitting, we should have for sure permits for each step about our CO2 storage phases, the capture, the pipelines, and the storage, the exploration. And we should have also the risk and the assessment done should be communicated with the public to build confidence. Enabling first mover projects. So if a country, they don't have already regulations about CCS. Even so, in the absence of this framework, legislation should have the CCS project in their legal regulatories to improve the project. Going to ensuring safe and secure storage, which is one of the main importance of legal and regulatory frameworks. I will go in details into this. Storage resource assessment for sure, because into all assessment phase, into all the storage phase, as we already said, an assessment should be done. Ownership of pore space, because sometimes it's not owned by the state, it's owned by a private sector. Monitoring plans, as we already said, but pre-injection, injection and post-injection is important to have monitoring plans. Storage site inspections should allow authority to have inspections during the project of storage from the authority part. Operational liabilities and financial security to ensure that the operator is financially capable of covering if a problem happened during the project. So we should able to cover this problem. And site closure, which talks about the conditions after the closure of a site, because we should have always someone responsible about closing of the well, the surface infrastructure, and all over it. Addressing long-term storage liability, it's also about post-closure. We should have arrangement if we want to transfer the authority from a part to another. International and transboundary issues, mainly it's related to transport, because usually we transport CO2 from a country to another, we cross borders, or we have reservoirs that are not in one country, so they will be in two countries, and they will affect each other. They will have two legislation and frameworks that could cause a problem. And if we're injecting in a reservoir and is connected to another reservoir in another country, also the pressure could have an influence on the other reservoir. So we should take care of it also. Facilitating CCUS is also about transport. If we facilitate and encourage the transport of infrastructure and CO2, it could help us more in the projects. And other keys are like the treatment of CO2 after removing it, the interaction with the resources, and the subsurface resources, like if there is oil and gas activities also underground. CO2, the transitioning from CO2 EOR to storage, because usually we used to use CO2 for enhanced oil recovery, which help the production. But after this, we can keep the CO2 underground and also add more to have it to have the storage project. So that's more about the issues. And if we want to talk about the regulatory frameworks worldwide, in fact, international standards are provided, which is an ISO, and it can provide like a baseline for all the frameworks all around the world to establish good legal and regulatory frameworks in their countries. Here are some examples of some legal and regulatory frameworks all around the world. In America, in US and Canada, there is a big work on the legal part of CCS. In Asia, it was very recent. In Indonesia, they published their legal framework also about CCS. In Australia, also a lot of work has been done since 2008. Europe, for Europe, a lot of work is being done on CCS, especially in the northern part of Europe. And for the legal part, EU has published its directive in 2009, which is from the European Parliament and the Council, and they published the directive about geological storage of carbon dioxide, and they admitted 2023 April 2009. What concerns Italy? For Italy, in 2011, the Italian law concerning CCS was declared. I kept here a link if someone wants to check it. It's very similar to the EU directive. It's a transposition from the EU directive, for sure with some modifications that fit with Italy. If you want to go more in details about Italy, there is, as we said, a big interest for CCS project, a lot of research and studies. And in fact, the first CCS development project is going on in Ravenna. So it's a project between ENI and SNAM, very well-known companies in Italy, for their first CCS project in Italy. It's going in Ravenna because we already know that Ravenna has a lot of depleted gas reservoirs. So they're using this depleted gas for the CO2 injection. Their main source of CO2 is power plants from ENI. and they will transport it from the plant till the storage by pipelines. Till now, they are in the first phase of construction of the storage project. Their potential impact by 2030, they're estimating to have 4 million tons per year of CO2 storage. It's starting in 2027. And after, with all this work, they estimate to have a capacity after 2030, 16 plus million tons of CO2 per year stored. But this is after 2023, and it's an estimation. Hopefully, it will be made. Here is a video also. I put it if someone wants to know more about this project going in Ravenna. Last part of our presentation is CCS deployment. So we spoke about how important CCS is and what are the issues and the regulatory part. So how we can help CCS to deploy more. First, for sure, we develop policies that support CO2 storage. Because as already said, if a project is legal, it kept more people to work on it. So we should include CCS in national energy and climate plans and develop CCS roadmaps. Ensure legal and regulatory frameworks account for CO2 storage specific need. So if there are already laws that affect CO2 storage, we should review them. And regulators should have people, staff that already know about CO2 and can help them making these rules. Because for people from outside the oil and gas domain, it will be like a bit mysterious what is CO2 storage. So we need for sure expertise to help us during these legal and regulatory frameworks. I support the development of expertise and competencies, as we said, by government if they encourage CO2 storage site. And also it can be done by oil and gas companies because already CO2 stored underground. So people like working in oil and gas production have a big idea about reservoir storing, reservoir modeling, and all the phases related to oil and gas production. And if we give them more knowledge and competencies about CO2, these same people can work also on CO2 storage. Private sectors, investment in storage site assessment and development. For sure, we need an investment from private sector. From the insurance industry, they should support more CO2 storage deployment with their investment in this area. So here I kept a bit of reference that I used in my presentation if someone wants to look at them. And thank you.
Thank you, Antonella. So you stay here with us for a question from people if they would like to ask. Just if you can raise your hand or write in the chat, and we will take them to Antonella. I interrupt the registration now, so we are free to